Okay, so hi guys. Today I'll tell you how a code is run, how a code is run inside a computer. Inside a computer. Okay, so supposedly I have to write a code of a Python of adding two numbers. Supposedly x equals to 2000, y equals to 3000, and z is equals to x plus y, and we have to print z. So once we click it, we see the output as 5000. But then how does it work inside of a computer? That's what we are gonna right now see. So right now we are gonna see, like, I have opened my terminal VS Code. I've just written it, so I'll just write it again. Let's say x is equals to 20, y is equals to 30, and z is equals to x plus y. Now we have to print z. Now let's just save this code and let's just run this code. Now you could see I have seen. Let's just clear this. Let's run again. Yeah, now you could see the output as 50 because that is what. But how does this Python run inside our code is what we're gonna see right now. So let me just explain you. So once you write a code, there are a few steps inside the computer that understands how the computer or how does it run, and everything is in a format or is like is a process inside a computer. So how does it start is, firstly, once you write the code, everything that you write is what you have written it in a Python language. Now the computer won't understand a Python language. So right now you have written your source code in your Python language .py. Now this is what you have written it. Now here is your computer. Now here is your computer. Supposedly it won't understand this language. So what does it understand is, it understands the language of 0 and 1, which is like a binary language. Now we have to convert this into this. Now how it gets converted is, once you, like, there is a step in between which is called interpreter. Now the role of interpreter is to convert the source code into uh, binary code. Now it's not simple, like, there is steps inside the interpreter as well. So the code directly does not get converted into the bytecode. So inside this, compilation is what happens. So compilation happens. Now the source code is compiled, and it is like a compilation step is there, in which this converts the source code into assembly code. Now assembly code is another language in which the code is, before it gets converted into the binary code, it gets converted into assembly code. Now that assembler is also, there's also step in assembler which converts the assembly code into the 0 and 1 binary code. So this is the binary code, and then it is being passed to the system. Now this is the first step that takes place whenever you write a code. You know that there's this compilation step, and then you get the output. And before that, the compile how the machine understand is, once you write a code, it is being compiled here into the assembly code is converted into the binary code, and then the computer sees this binary code. It is stored in its memory. Now I'll show you. Right now, here we have seen, now the code, now this file is being stored here, like in my C drive, in my SSD, it is stored in this location. So what happens is, once you so now, once you like save a file, supposedly it is saved in the memory. This is the SSD memory. See, now the computer cannot just read it from here directly. Now this to execute the code from here, there's a several steps that take place. Firstly, the computer, the CPU. This is our CPU. Now this is our SSD. This is our RAM. This is our input output devices. Now, after this, what happens is all these things transfers or everything in between all of these are being done with the system bus. Now supposedly the input output devices has saved something, and how does a computer know that input and output device? I told you BIOS is the key between input output devices or the hardware of the computer and the software of the computer. So once you click on a mouse, the BIOS will tell the computer that the mouse button has been clicked. So and then supposedly this is the input output devices. Now you have saved something. It is being stored in SSD. All these travel takes place with the system bus. System bus. Inside it, there is a address bus which takes place. There's a data bus. So address bus takes care of the addresses. Data bus takes care of the addresses. Now there's an interpret bus. Interpret bus is what supposedly your CPU is working something on a task that is being assigned on it, but then at the same time you click a mouse. The BIOS will tell the CPU that the mouse is being clicked. Now all those information or the signals is being transferred through the interpret bus. Now your file is stored here in the SSD. Now the CPU has to take actions. It cannot directly take it from SSD because otherwise it's like there is a sequential order that is followed. So the compiled file or the compiled file is stored here. Now what happens is once you run the code, then these files is being sent through these system buses. It is being sent to the RAM. Supposedly a file would have been in a HDD. Now if your CPU cannot take the access the HDD, like there's a system that is followed, so your HDD sends the data or the file or anything that is there to SSD. Now the SSD sends it to the RAM. Now there is a execution process before you see the output on your screen. Then these are the steps that is followed. Now the RAM, now what is this is your memory, main memory. Now here is what you have the file. Now there is a execution process or the instruction cycle, I'll say instruction cycle that is followed. Now we have written x is equals to 20, y equals to 30, z is equals to x plus y, and print z. So now these are the steps inside the file that is in that these are in the binary code. Now I have written it in this way because we don't know the binary code. Now this is the first step that the main memory will execute because here are the addresses of every file. Now CPU itself is consist of so many things. Now wait, I'll just show you. Let me create a new tab, or let me just do this. Yeah. So yeah, now here is your CPU. Here is your main memory. Here is everything else. Input output devices. Wait, I'll just create a new. So now that you have know that how the file is being converted, and now it's uh now your file is converted into your binary code. Now from your hard disk where the file is stored, it's sent to your SSD to main memory. Now the execution process, now the instruction cycle takes place. Instruction cycle. Now what happens is this is your CPU, here is the control unit, here is ALU. Now this is the ALU, this is your control unit. Now these are the temporary registers which I have told you. Instruction cycle takes place. This is your main memory. Now what happens is x is equals to 20, y equals to 30, z is equals to x plus y. Now print z. This was our code. Now this is written in binary code which the computer understand. All have their addresses. Now this instruction cycle is fetch, execute, and before that load. Yeah, load, fetch, and execute is what the instruction cycle is. CPU will load everything, load this data. Firstly, this it will get loaded. here, then it will pass the address here. Then these are the temporary registers which store temporary address and the temporary data. All these transfers are also through the system bus. Now the instruction cycle is taking place. Now the address of the first thing takes place in a sequential order. Now this address is stored in this register, then it's passed to this register, and it's the address is passed here. Now the control unit sends a read command. It sends the read command, and here the x is equals to 20 data. It is being passed here. Now this is what is the first thing that takes place. Now the ALU have a register here. Now x is equals to 20 passed gets passed here. Now the second command takes place is y equals to 30. Now x equals to 20 done, y equals to 30 takes place in the CPU. All these commands happen in very, like, you cannot even notice all these commands take place in like a very less time, that you don't get to notice all of these things. Then the second command takes place of this is the CPU. Now second command takes place, the CPU loads these data, second y equals to 20, process the address of it, then sends the data, then he sends a read command here, then the read command reads the data inside this address and sends it via data bus to the third register, and third register see y equals to 30, so it sends it to the register saying y equals to 30. Now these two things are stored. Now there's a third return, z is equals to x plus y. Now addition of the statement is passed. Now z is equals to x plus y. Now addition of something, addition of these two takes place. Now the CPU, this all things takes place inside at single time. So now the control unit takes place. There is a register decoder which takes the command, converts it to to how the CPU will understand it. Now z is equals to x plus y. Now he had the x value before, y value before. Now the ALU will perform task of x plus y and store it in z. Now z will be stored with a 50. Now the register here stores the value of 50. He sends it to here, this register, and the 50 is stored here. Now the 50 has to be sent back to or the 50 is to shown to your screen, like your computer screen has to see the output as 50 once you run the, so all these execution takes place and everything takes place inside this. Now this 50 is being shown to your display. Now this how this 50 is shown to your display is via GPU. It's like the graphic processing unit. It is just like the CPU, but it takes it like handles all the things related to the graphics, like all the images that you see in your computer, all the videos and everything, the white screen and everything that right now what you're seeing is also through the GPU. So the 50 is taken to the via GPU, and all these traveling takes place through the system buses. It takes place and it's displayed on your screen. Now before in this step, this 50 right now is in a binary number. So before it's is being shown to your screen, supposedly you have your CPU with your answer as 50, but this is in a binary number, binary code. Now it bit to bit before that, there are, it right now is in a analog code. Now there's a conversion that takes place analog to digital, and then this is the thing that we are able to understand. This digital is what we means by this is like language and everything that you human and we humans understand is being converted by the computer. Now the computer converts this, or the CPU send this in between this, the converters convert this analog into digital, or these output devices that you have, these have output devices converts from analog to digital. Now the input devices converts these digital things into analog things. This is what humans understand, this is what computer understands. So this is being converted and in your screen displayed as 50. Now once you run the code here, you are able to see 50. This is because now once you run this code, now you are able to see 50. Now you're able to see 50 in like within a second, with less than a second it took place. So all these things which I told you right now, all the other things which I told you of conversion and everything, so these takes place in very less seconds. So this is what happens, or a computer code inside a computer takes place. So right now I've told you how addition of two numbers takes place inside a computer. Uh, so this is what addition of two numbers inside a computer, and this is what is being shown to you. Now, this is a Python code for addition of two numbers. Now let's again take a Python code just for you to better understand. Let's again take a Python code and let's say 10. Now Z will be, or let's just say print x minus y. Now this is what we are saving it as. Now let's just run this code. You'll be able to see 20. Let's just run again. Now I have run this code and I have seen the result as 20. Now again, how does it all happen inside the computer is what I'm gonna be telling you. Let's just see. Now the first thing first, what happens is this is the source code that we have written here inside a uh, so this is the source code. This is the source code. Now the first thing which will happen is it gets converted. This is the interpreter step. Machine code. The computer understands. So first thing, compilation takes place. It converts the source code into assembly code. Now this is the conversion, then the assembler is there which converts this assembly language into 0 and 1, which is like a binary thing. Now the computer understand that, yeah, okay, this is your source code. Now before the computer understand this file is stored where you can see this is where it is stored at this location, which is like a SSD of me. Now the computer knows that this file is there and it has to be executed. Now the SSD sends the file or the thing that has to be executed to the main memory, and then the CPU and the main memory perform this instruction cycle which gives us, or which performs the task that has been given to you. Now now this is the thing that happens. Now this is the instruction cycle, this is the main memory, this is the CPU. Now the first thing is x equals to 30, y equals to 20, print x minus y. Now first thing, uh, now here is the control unit, ALU, registers to store temporary data. Okay, register to store temporary output. So now first thing, it takes place in the sequential order. The first thing that you have written in the code is x equals to 30. Now x is equals to 30 is the first thing that the address of this is stored here in this register. It is being passed to this register. Then the CPU sends a read command or a read signal. All these things take place with the system bus. So inside the system bus, there are three types: address buses, interpret bus, data bus. Address bus takes the addresses, system bus, data bus takes the data inside those addresses, and the interpret bus is like once you click a mouse, then all these things like clicking of mouse, the BIOS tells the CPU that a mouse clicks. All these signals are being transferred through the interpret bus. Now x equals to y, the control unit of the CPU sends a read signal to this address. Then at this address, whatever the data like x equals to 30 stored here and everything gets stored here. Then it sends to the output of the registrar. Then the second y equals to 20 take place. address is being sent to the first register, then the second register, and the CPU works like a read command is sent at this address. Whatever the data that is stored at this address is being sent via data bus to this register. Now this register stores the data and sends it to the ALU to perform the whatever task or arithmetic. ALU is like arithmetic and logical unit. It performs the task. Now the third step is print x minus y. Now x minus y. We have to x minus y is a instruction that is given. Now what happens in the third step? The address of this thing is being stored here, then the address is being passed and a read statement is being sent here to see whatever the data inside the inside this address is there. Now the data of the address at this address, the data which is stored at this address is stored here, and then there is the controller that takes place. Now the controller see that x minus y is what we have to do. We have x in the CPU, we have y in the CPU memory. Now the ALU comes into play. ALU do the x minus y calculation, sends it to the register and say, hey, the answer of 30 minus 20 is 10. So now the 10 is stored in this output register 10. Now once this 10 is stored, now what happens is the CPU has the 10 written as an answer to you. Now the signals is being passed by now this is the display. Now CPU have the answer, the task or everything is being executed. It sends back the signal or the via system bus and everything. Now the showing of these things, the output device display. Now the output devices, what it does is analog to digital. Now this is what is being done. Now these signals are in 0 1 format, like CPU have converted this into binary. The 10, the output is being in a binary number or a binary code. Now the GPU performs the task. GPU perform the task of showing the output on display. Now this is 0 and 1 is being converted to like 10, like a source code, human understanding language. So 0 and 1 in the process, it's being converted, and so this is the analog which human computer understand. This is the digital which human understand. It is being converted from analog to digital, and it is being shown to the display via GPU. Now this is the process of Python in which the x minus y is being uh, uh, print x minus y. So a Python code, how it works inside a computer is, once you click on run, the interpreter and everything gets converted, sends to the location, is it's stored in the location, sends to the main memory. Execution cycle takes place. Execution cycle, then the output comes place. The output is being converted into back to the digital form in which the original source code was written. Then this is the output we are gonna see here. This happens in very less seconds. That's why it's like called as uh, what happens inside a computer is how the computer understands your code, converts it, and executes the task and everything. And this is how the Python program for subtraction of two numbers takes place. Well, yeah.